too long ago when we did it, right, guys? So, synthetic division.
Wait, is that where we have the numbers?
Yeah, which is a lot easier. We didn't get to do long division. Maybe in algebra 2, I don't know if you guys did long division, but really long, right? A lot of process. Synthetic's really nice, short and sweet, right? So here we go, guys. Best way I can show you this is with an example. So let's do example 1. Okay. Now, when you're doing these problems, they're not going to come pre-announced to you, hey, this is a OA problem, right? They're just mixed in. So you have to still do Bobo, Button, or Betsy. Okay, so what do we have here out of those? So Bobo, Button, or Betsy? Button, right? It's bigger on top. So is this a button problem? Okay. Which means we have no HA. The following question after you establish that is it bigger by 1? Yes, it is bigger by 1. Okay, so the fact that it's bigger by 1 implies that we have a OA. Okay, this is the process. That's how you establish. First you do Bobo, Button, and then if it's Button, is it bigger by 1? So it's the powers. When you went to the restrooms, like the difference between the powers has to be 1.
Oh.
So let me show you real quick. Like here, see the difference between these two would be 2. So this would be no good.
Oh, okay.
That makes sense? Okay. Okay, here we go, guys. So once you establish that, we go to synthetic division, okay? So here we go, guys. Little refresher of synthetic division. It's been a little while, right, since we did it. So you start off by putting the highest power and you work your way down all the way to the number, right? So if you had started with the x to the 8th power, you would start x8, x7, x6, x5. You just work all your way down. And we put the coefficients and the constants. So in other words, all the numbers. Now, last unit, we had a big old issue, like it was problems for us. This right here is called a factor, right? But we don't divide by the factor, right? We divide by the root. So if that's my factor, what is the root of that? 2, right? It's when you solve that. So we don't divide by -2, we divide by +2. Okay. Now, just little refresher on the process. The first number drops straight down, right? And then we multiply this times this, multiply. And then we do 2 times 1, and the answer goes to the top. And then inside of here, you're always going to add. It's always add. You'll never subtract because it's adding down. 2 plus 2 is 4. And then you just repeat that process. Multiply, add, multiply, add. So I multiply again. 2 times 4, 8. And that last number, you guys remember what that last number was? The remainder. Okay, last unit, the remainder was a huge deal. Remember if it had to be a 0 and all that? On this one, you can ignore the remainder. It doesn't matter. It's not going to affect our answer. Okay? It doesn't matter what the remainder is. Because last unit, it was a huge deal what the remainder is. Okay, here it doesn't matter. All we want is this. Okay? That answer is your equation. Okay, and if you remember, the equation is always 1 power less than what you started with, right? So if you start with the x2, this one will be x1. After the x comes a number, right? So these just came from here. Okay. If the top one was the x3, then you would start with the x2. Okay. And so, ladies and gentlemen, this right here is the equation of your OA. Okay. It's easy, but it's not just a number. Okay, it's a diagonal line. So that's why, since it's a diagonal line, that's why it has a slope, and that's why it has a y-intercept. Slope-intercept form, back from algebra 1. Okay. It has to have both. Okay. Now, I'm going to give you a quick visual of this, just so you can see a diagonal. Okay, which one was it? It was this one. Okay, so here's the equation you just did, and here's the diagonal. Let me zoom in a little bit better. Okay, there's the diagonal line. You see that orange line? Okay, diagonal asymptote. And look, you could look, like you can go like this, and it looks like it's on top of it, right? Like it looks like it does touch, but the minute you zoom in, it's never touching. This is gonna approach it, approach it, approach it, approach it. Is that good? Make sense? Okay, so here we go. That's the gist of it, guys. So now let's try an example. 2. You're gonna need a little bit more time, but let's do x squared plus 2x plus 1, x minus 1. Okay. So establish, it's a Bobo, it's a button, it's a Betsy, and then if it is one of those where you button bigger than 1, find that oblique asymptote equation. If you get stuck, ask your neighbor or ask me. Okay, so I'll walk around. Got 2 minutes. You're not sure? You got to, okay. Opposite of that one, so positive one. It's always going to be the opposite. X plus 1, X plus 3. 2 plus 1. You don't have to, but it's not wrong if you do. Yeah, it's the same. All right. Diego, is this a button, Bobo, or Betsy? Button, right? Is it bigger than 1? Yes, right. 2, 1. So we can divide. Is that we good? I walked around and I saw you guys. So we divide 1, 2, 1, divide by 1. Drop the 1, 1, 2, 3. The remainder doesn't matter. I saw a lot of you had this equation. You can put the 1 or not put the 1, but it's y equals x plus 3. Okay. Be honest, how many of you had that equation? Excellent, guys. Look around. Okay, that's almost everybody. Okay, last thing. Exit ticket. Okay, go to the Bellworks section. Under today's entry, you don't have to write down the questions. Just put number 1, number 2, and